Okay, today is a very special day for me because today I get to look at the DuraTech 140 amp multi-process welder. It says that this is a 3-in-1 because it is MIG, DC TIG, and DC stick. They should actually call it a 4-in-1 because this can do shielded gas MIG as well as flux core MIG. So you can do a lot of things with this welder. This is a DC welder. It is a single phase, so you're going to plug this directly into your household outlet. But 140 amps, this is going to be more than capable of doing shop work. That is awesome. Okay. So we got our stinger, and it is encased fully in plastic, so even if you set this thing down on the table without the electrode in it, you're not going to worry about that thing sparking, so that's good. It is a standard insert and twist plug, and we do have, it's a very nice strong spring on there, but that is cut, so you can insert that rod from the front, from the top, or at an angle. And we got our grounding clamp. This has nice thick contacts all the way around. One thing I love to see is you can see this little band right here. So that is going to make sure that no matter which side you connect to your piece, if you got to like connect it onto your table or something like that, you don't have to worry about this pin carrying the current. So no matter which side is making better contact, this band will make sure that you have the best absolute contact. We got that same push and twist pin. We got our electrodes for our MIG. We can see they have different size holes in there, and they are labeled. This one is for up to a 0.035, and this one is for up to a 0.023. I'm going to be using 0.035, so this is the one I'm going to be using. And they actually gave us 2 wire feed wheels. So this one, you can see the plus on there. This one is going to be for solid core wire. This one is going to be for flux core wire, and you can see the difference in there. And they do have 2 different sizes. I'm going to be using the 0.035, and if we swap that around, there's a 0.030. So you just make sure that your wire is going into the groove of the correct size of the correct wheel. And if we look closely inside there, we can see that there are ridges in there, so that's going to help to provide a nice good grip on that wire. It is still very important to make sure that you're getting the correct size wire, because if you do not, you can experience feeding problems and you'll wonder what's going wrong. Oh, it's actually not as heavy as I was expecting. That's still a beautiful big beast though. I love that color. It's actually, I didn't think I was going to like this color, but I really like that. We also got a full instruction manual in that box. Oh, wow. So first thing I have to say, nice thick extension cord. I love seeing that. So this part's a little bit interesting. So this actually has an adapter on the end. This is a 15 amp adapter to a 20 amp adapter. Now all the outlets that are going to be in a house in the US, they're all going to have 20 amp plugs, so it doesn't matter. And plus the tip is actually exactly the same, so we don't even need to use this. So on the back we got our power switch, and we got a spot for our gas. So if you're going to be using MIG and you want to use gas MIG, then you can plug your bottle in here. Also, if you're going to be using TIG, you also need to use shielding gas for that. So the other options are flux core MIG and stick welding. With either of those, you do not need to use shielding gas. We also got a list of the ratings here on the back. So we got MIG, stick, and TIG. That is a nice looking front. So I do like that they got this on here, so if I do drop anything on here, it's going to hit the case and it's not going to break off the controls. That's actually real nice, but plus, I really just like that they put these plastic guards on here. So many times I've seen welders that have bent edges. The fact that they put this on, that's actually pretty nice. It's not even really a plastic. It's more like a soft plastic or a hard rubber. That's great. We do have air intake here and there is active cooling in the back, so there's a fan in the back that's going to pull air through it. They actually have a button for cold wire feed. That's really cool. So what that means is if I want to get the wire going through the gun, so I want to feed it in for the first time, but I don't want it to be hot. So that's very nice. Then we got our selector here. So we got MIG, MMA, which is stick, and lift TIG. So we can just hit that button to select between those. And it looks like our MIG is going to be always connected. So this isn't going to be disconnected. You just keep this on all the time, which is not really a problem for me. So the cable has everything built in one. You're not going to have a big tangled mess, so I like that. And then this is going to be the main thing that I use all the time. And even I got a little hook here on the back. So when you're done, you can just take that and hook that right onto your table. So here's our nozzle. We already got a tip installed. So we got actually a total of 3 different tips. So that's kind of cool. Good feeling trigger. So that's nice. And I do like that they actually have some texture on there. So not going to worry about our fingers slipping on that. So yeah, looks like a good looking MIG. And we do have a nice long cable on here. So this is like 8 feet. That's fantastic. This is going to be whether or not you're going to be doing DC positive or DC negative. And the big difference there is if you're going to be using MIG with shielding gas, then you want this to be DC positive. Now on older machines, what you would do is you would actually open up the side. There'd be 2 wires in there. You would have to undo a couple nuts, swap those wires, tighten the nuts back down, and that's how you swap it. With this one, it's much easier. You just got this little cable right here, so you can plug this in and you can make it DC positive and then plug your grounding clamp into the negative. Right? So that's how you do DC positive. That's how you want to hook up this welder if you're going to be welding with shielding gas. Now I'm going to be doing flux core, which is DC negative. So we do the exact same thing, except we plug it in right here, and then the grounding clamp goes to the positive. So that is how you have to run flux core. If you don't run it like that, you're going to notice that your welds are just not coming out the way that you want it, and it's as simple as that. This is a very easy and very user-friendly welder, so I love that. Now these two dials can change functions depending on what you're doing. So if you're doing MIG, this is going to be your wire speed. Oh, that is a nice feeling knob on there. All right, that's great. And then this is going to be your volts. If you're gonna be doing stick welding or TIG welding, this is your amps, and then this is your volts. So let's get a peek under the cover. So one thing I do really like to see is they actually put a cheat sheet on here. I love seeing that, especially for new welders or even for me, where I just want to have something where I can reference. This is a fantastic tool to have. So if you're using solid wire with gas, and you use this part of the table up here, and if you're using flux core like I'm going to be using, you use this part of the table right here. I'm going to be using flux core. I'm going to be using 0.035 inches. So if I was welding 1/8 inch plate, then I would want the wire speed to be at 6.0, and I would want the voltage to be at 16.5. So that is a nice easy way to at least get close, and then if you want to fine tune it from there, you can. And it even tells us if we got electrode positive or electrode negative. If we're going to be stick welding, it actually says to use electrode negative, and this is in metric, not in inches. So it says for a 2mm electrode, if we're going to be doing 1/8 inch steel, use 65 amps, and if it's 2.5, use 80 amps. So I usually use a 3/32 inch rod, which is going to be right between a 2.0 and a 2.5, so that's going to be probably around 72 or so amps. So this is going to be where we hold the wire. We want to make sure we don't lose any of these parts. So we got the nut, we got the spring, and we got the holder. Now what I do like about this particular machine, you can see that this rod inside is thinner, so that can hold a 2-pound roll of wire, or we can hold up to a 10-pound roll of wire, because there's actually enough room in here for that. Now some of these machines, the wire feeds in from the top, so you put the wire in clockwise. This one is counterclockwise, so we want to make sure that we put the wire in the correct orientation. And we also want to make sure that we're not doing anything to the end of the wire, because we don't want this thing unspringing before we actually ready to go. So I'm just going to drop this on. Then I'm going to drop in the guide. And it just has some slots where it sits in. And then the spring, and then the nut. And you want to have this so these flats are facing outside. Now you can see that both of these types of wire are exactly the same. These are both Lincoln Electric 0.035 inches. Make sure that you get the correct size wire for the wheels that you're using, because if you don't, you'll have fitting problems. Also make sure that you get some good quality wire. I'm using Lincoln Electric here. You can use whatever you want, but poor quality wire can give you problems, especially with flux core wire, because there's a lot of parts involved in it. And if there's anything like, even if the diameter changes a little bit, you'll have fitting problems. There's a lot of things that can occur. So good quality wire is important. So to get the wire in, we have to get it fed through here, over the feeding roller, and then through the line. We'll start out by loosening this nut, and then that'll drop down and out of the way. So you can see all that we have that really pushes that wire in is this bearing and then this feeding roller. Now the good part about that is we still got our 2 previous rollers, but we got this one, so there's actually a total of 3 different rollers. So this one is a 0.03V, so it's a V groove. That means it's for solid core wire, or a 0.025. So there are 3 different options for solid core wire. For flux core, you only got 0.03 and 0.035. Perfectly fine for me because I only want to use 0.035. So I got my K groove. This is a 0.035, and I've got that facing out so that this groove will line up with my channel. And I'll just drop this in. And it doesn't matter how you fit that in. I do really like this mechanism. Like, that's very nice. With a lot of the other welders, you have to get like screwdrivers and tools and things out. This is all toolless. That's pretty awesome. So I just realized that I actually had this thing on backwards. It's got 2 directions. You can put it in like this for these shorter rolls, or you can put it in like this for the bigger rolls. There is that little lip on there that's going to sit against it. So I'll put that on properly. And the reason that we're doing this is because we want there to be a little bit of tension on this roll. There we go. So before I could just take this thing and spin it, but this is what it should be like. It should be a little more stiff. Now this is the part that can mess up people if they've never done it before. So I'm going to take the wire. We don't want to let it go, because if we let it go, it will unspring and then it'll be a problem. So we want to get that out to a point where we can start feeding it through here. But we also don't want to have all these bends in this wire. I'm going to cut all that nasty stuff off. I'm going to bring it back, feed it into there. I'm going to get it to the point. And of course, you know, it should probably go without saying, but just to say it anyway, we do not want to have the welder on while we're doing this. Now, worst case scenario is I mess up and I bend this thing a little bit. If that happens, that's okay. We just take it out, cut off a better piece, and get started again. Because what we don't want to have happen is we don't want this wire poking anything on the inside of the of this cable. There we go. So we are started. I'm going to drop this down and put a little pinch on it. Now with flux core, the amount of tension that you put on here can make a big difference, because if you put too much on, most people, they just want to crank on it. If you put too much on, you'll also have feeding problems. So you just want to get a little bit on there just so those wheels can grab it. But you want it to be loose enough so that when you pull that trigger, if you put your finger on the wire, you can actually stop it. So it needs to be tight enough to be able to drive it, but still loose. That is what it should look like when it's done. So we got the wire in the groove and then going out that tube. And we don't want anything that can possibly get in the way here, so I'm going to take off the nozzle and I'm going to take off the tip. So the tip that they had included was a 0.030. So we got a 0.025, a 0.030, and a 0.035. So just to get the wire fed through, I'm going to take everything off, and that way I don't have any obstructions to get in the way. Now I want to have the door open so I can make sure there's nothing getting kinked inside of here. I'm going to turn the power on. All right, I'm going to put it on cold feed. Oh, apparently that will feed by itself. So I want to get the length that I'm going into as straight as I possibly can, and then I'm going to hit the cold feed. All right, looks good. So as it's moving, it's not binding or twisting or anything like that, so I know we're good. So now I'm going to pull this straight all the way. And I'm just going to keep on pressing the trigger. Come back, make sure. And it's kind of hard to see from, I mean, this is good 8, it might even be 10 feet long. And there we go. I know if I hit the cold feed. This is a much faster method by hitting that cold feed, but I do think that you need to have 2 people to do that. And we can reattach the tip. So that 0.035 is a very nice fit on that wire. You don't need to crank this, you just want to make it a little tight. And put the nozzle back on. And then we'll cut off the extra wire. So we're already on MIG, wire speed. I'm going to be going, I think it's a little bit under an 1/8 inch steel. So it said 6, so I'm going to go with, what does it say? Yeah, let's go with 6. And it says 16.5 for the volts. So let's go with that. Okay. So 2 things, that was very smooth, so I love the way that that was actually running, but it was way too hot for this little piece of metal. So it burned a hole right through it, and that is the back side of it. So I gotta turn that way down. Now the good news on this metal, which is almost 1/8 of an inch, this little welder can definitely weld this, no problem. Now that we're hot, I'm gonna start using the nozzle dip. So this is all it is, and all this is going to do is it's going to help to prevent all that buildup from building up inside the nozzle. So if you do ever decide you want to go to gas, you're not going to have all that buildup in there blocking the gas from getting out. So this stuff is very important. And whenever you use this, it's a good idea to trim off whatever it is that you just dipped, that wire. So that dip helps to prevent things from sticking, and we don't want that contaminating our weld. So we had it set for 1/8 inch. Let's go ahead and bring that down to a 3/32. It recommends 4 and 15.2. Okay, let's see how that goes. Okay. So maybe a little thin. I think I might have gone a little bit too fast, but this guy, look at that penetration. This little thing can definitely weld. I am very happy with that. And probably what's most important to me, like when I was listening to that welder, it was coming out beautifully consistently. That's the most important thing, because without a consistent feed, I can't weld. And this thing actually does it. This little guy can run. So I'm going to do a couple more and we'll see what we get. I'm going to try to slow it down a little bit, maybe get that a little bit thicker, but I'm afraid if I go too slow, it's going to start building up too much heat on it. But I mean, ultimately, that weld that I just put down, that would definitely hold something together. For a 1/16, go with 3.3 and 14.6. I'm going to try that, and then I'll slow down that weld a little bit, and I'll see if I can build that up a little bit. Might be too light for this, but we'll see what happens. So yeah, slowing that down definitely let that heat build up too much. So I could do it like that. Like, look at that. That's that's way too hot. But I mean, even for their settings for a 1/16 plate, I can get a smooth, consistent run with this welder. So I'm going to bring this down to a 20 gauge, which is 13.2 and 2.2. Now I can definitely still get a weld on this thing. I mean, this is too light if I was just doing like that little tiptoe where I go forward and then back a little, forward, a little back. But I was trying to do the weave, and it just builds up heat too quick. So we got these settings much lower. I'm going to see what I can do with this. So I think we are about there. That one came out a little crooked. There we are. See, even at that light setting, I was able to get good penetration. So this is a monster. That is a beautiful machine. I am very happy to have that.